Attention pre-meds, pre-dents, nursing students. If you panic when you see formulas like this, just watch this and you'll be fine. A solution has an osmotic pressure, that's what that means, of 7.35 atm, a temperature of 27 degrees Celsius. Find the molarity of the solution. So, first things first, what's the molarity formula? I need M to be by itself to find out what the formula I need to use is. I don't want to know what MRT is equal to. So I'm going to divide both sides by RT. If I do on one side, I do to the other. RT. And I have M equals osmotic pressure of RT. Okay? So, temperature has to be Kelvin. To get into Kelvin with degrees Celsius, you add by 273. You're going to get 300 Kelvin. So I'm going to plug it in down here. So we have 300 Kelvin times an R, which is a gas constant, which will be given to you guys as the following. 0.0821 liters times atm, all over moles times Kelvin. That is all in the denominator. Now, I'm going to move this bad boy away. You may be wondering, well, great, but what's the osmotic pressure? Glad you asked. It's up here. It's 7.35 atm. Which would get me the big M, right? So check this out. ATM cancels out. Kelvin cancels out. And I get this value when I first multiply these in your calculator, just to be very clear. Then take 7.35 divided by that value. You're going to get M equals 0.298. But I want to be clear. You have liters of mole that didn't cancel out in the denominator. Okay? Here's the deal with that. R has liters over moles in the denominator. And since the whole R term is in the denominator of our equation, that fraction flips into moles over liter. So liters over moles becomes moles over liter, which is exactly what molarity is. Ain't that cool? So this is your final answer. I really hope this helped. If it did, comment what you thought the answer was. Subscribe.